Continuing with our linear regression unit, we have here today an example of a scatter plot. The first part is our scatter plot, and our second part is our residuals from that scatter plot. So imagine if you took that angled line and you put it horizontally, and the residuals are then just shown positively or negatively according to the linear equation that we put in here. So this is our scatter plot. Let's say we have a surf shop, right? So this is our surf shop, and this is our predicted revenue versus how much revenue that we have. So what are some notable things? Let's first look at some notable things that we can see and talk about the surf shop. Well, something noticeable or notable that I notice is that there is more variation. If you look here, as we go towards the middle, there is more variation, right, from here compared to the beginning, and then the variation kind of like decreases a bit as we go towards the end of our season for our surf shop. So that is something notable that I can say here about the surf shop. Let's label our axis here. Let's say down here our X is days. So these will be the days. So after 20 days, you get this much, and it goes up to 50 days, covering our sales. And here, the side is revenue, right? Or dollars, how much we make as we go on. And we'll say these are in thousands. So instead of just, $15, we're actually making 15,000 as we go. And from that, and if we look at our graph, let's say our R squared is 82%. So our R squared will be 82%. Let's say let's label our variables and our coefficient here. Our variable, first let's say find our constant. Our constant is always going to be where our predicted line starts out with. So our dotted line here, so this right there is our constant. Let's say that is 16.8, our constant there. And let's say and let's give our slope of when days is going to be 0.95. All right, so what does all this really mean? Well, first, our R squared, as we say always, our R squared is our variation. So here, this is the variation. And we could say that our days account for 82% of the variability or the variation in our revenue. So that is what our R squared would equal. What does if we have to think about it logically, if we were to write this in an equation, our equation, remember y equals mx plus b, but this is written a little bit differently. So here our equation would be revenue would equal, we start off with a constant, it's actually 16.8 plus 0.95 days. So then what about our correlation, right? So our correlation is going to equal the square root of our percentage, which is 0.9055. So that is our correlation. Once again, our correlation is also called our standard deviation. And if we were to say, oh, okay, what would you expect from a value that is 2 standard deviations below our line, which means it was probably a bad sale day. Maybe, it had a little rainstorm. So then we take our 0.9055, double it. Gives us a 1.811, so below, that would be how much it would be below our standard deviation. Let's think of another example. Let's say, what if we had a particular revenue? What would be our revenue would be if on, let's say, day 22, however, the residual now is 0.62. So that is our residual, positive 0.662 for our residual. Well, to just find this, we put it into our equation here. Times the day. This gives us 37.7. However, with the residual, we have to remember to always add in our residual at the end. So I'm going to add our residual, and this should be our profits in thousands on day 22 with a residual of 0.62.